Welcome to Farlaba Drive Time. In today's video, we will discuss about microstepping and how it can be used to reduce parasitic effect and vibration for stepper motor. First, let's take a look at an animation to better understand how a stepper motor works. You can find this animation in the application notes on our Farlaba website, and you have the link in the description of the video. So on this animation, we can see here a representation of one of our stepper motor. In the middle, we have a permanent magnet rotor, and we have the two phases, the A phase and the B phase. So these are the coils that are powered, and when you power the coils and have a current flow through them, this will generate a magnetic field. On the right, you see the phase diagram that shows how the different phases are powered. If you are rotating in full step mode, we will simply power alternatively the two phases so that the rotor magnet follows the magnetic field. If we take a look, this will look like this. As you see, the rotor magnet is following the magnetic field generated by the coils. Now, if we take a look at microstepping, we are actually going to power both phases at the same time. If we just take one single microstep, we see that both A and B phases are powered. This time, the rotor magnet can make some microsteps in between the full steps. On the right side, we see the phase diagram, and we see that there are different current steps that looks like a sinus. So if we make the rotation, we see that the rotor magnet can have a higher resolution as it has many more microsteps in between full steps. So the main benefit of using microstepping with stepper motor is that you reduce the undesirable ringing and resonance effect of the stepper motor. This is especially important at low speed because you are close to the resonance frequency of the motor. Additionally, as you will have less ringing effect, it will be gentler for the mechanical actuation, and you will increase the lifetime of the stepper motor. We will now proceed to a practical example. So I will rotate this motor at 60 RPM, so 1 turn per second, in full step mode. As you can see, the motor is vibrating, and you can clearly see the overshooting and the resonance effect in between the steps. We will now make a modification to the code and use microstepping at this low speed. So now what we will do is we will use 32 microsteps per full step. So we have here the code that I used to rotate the motor in full step mode, and we will modify in order to have 32 microsteps. So I replace this 0 with a 5. This corresponds to the 32 microstep. And we will then modify the different acceleration and speed parameters. So we can open the parameter calculator here and calculate the 4 important parameters, so velocity, acceleration, pulse, and ramp divisor. So we select the 5, we want 32 microsteps. And again, we will enter the same speed and acceleration. So we want to have 60 RPM, and we put also 60 for the acceleration. And here are the new parameters that I will use in the code. So I've already prepared the code, and now I can start the rotation of the motor with microstep mode activated. Now we see that with microstepping, the movement of the motor is much more gentle, and we also see that we don't have this overshoot and vibration effect that we had in full step mode. Now there are a few things to consider when using microstepping. Although the resolution increases and the motion is much more gentle, the accuracy of the stepper motor is not going to be increased. You will have the same accuracy when you're in full step mode or in microstep mode. So a very precise positioning cannot be achieved with microstepping. Another important point is that the incremental torque will decrease when you increase the amount of microsteps. What this means is that when you're continuously rotating, you will have the same holding torque and the same dynamic torque whether you are in full step mode or in microstepping mode. However, during the startup phase, when you go from 0 speed and slowly increase the speed, when you are using microstepping mode, you will have only a small incremental torque per microstep. This means that you will have to actually do a few microsteps until the motor is able to beat the friction torque, the load torque, and the detent torque. So there can be a lag between the expected position of the rotor and the actual position of the rotor. So in this video, we've seen that microstepping can reduce the resonance effect of the stepper motor and produce a gentler movement, especially at low speed. We've also seen that it can increase the resolution of the motor. However, it does not improve the accuracy and it will reduce the incremental torque. If you have any other question, you can leave a comment under the video, or you can ask questions directly to your local sales team. Please feel free to watch our other video on our channel if you're interested in other topics. Thank you and have a nice day.